Ever wondered why the focus is on Mars and not Venus for terraforming? Isn't Venus our closest planetary neighbor? Indeed, the cosmic dance of our solar system places Venus, on average, a mere 41 million kilometers away from us, compared to Mars, which is almost double the distance at 78 million kilometers. Now, in the vast expanse of space, these numbers might seem insignificant, but when it comes to interplanetary travel, every kilometer counts. Using current propulsion technologies, a one-way trip to Venus would take around 5 months, whereas reaching Mars would require a more patience-testing 9 months. But what exactly is this terraforming we're talking about? Well, in the simplest terms, terraforming involves altering the environment of a planet to make it Earth-like or habitable for humans. It's essentially gardening on a cosmic scale, cultivating the barren soils of distant worlds until they bloom with the potential for life. Why does terraforming matter? Think about it. The Earth is not getting any younger or any less crowded. In the quest for survival and expansion, humanity has always looked to the horizon. First, it was the next hill, then the next continent, and now it's the next planet. Terraforming is not just about survival, it's about the evolution of our species. This brings us back to our initial question. Why Mars and not Venus? After all, Venus is closer and therefore quicker and cheaper to reach. It also has a similar size and gravity to Earth, which could make for a more comfortable living environment. Plus, its thick atmosphere could provide protection against harmful solar radiation. So, on the surface, it seems Venus should be the obvious choice for terraforming, right? Well, not so fast. Venus, despite its proximity, presents some unique and daunting challenges. Imagine a world where the surface temperature averages 462 degrees Celsius hotter than the surface of Mercury, despite being further from the Sun. This is the reality on Venus, where temperatures are sufficient to melt lead. But the heat isn't the only obstacle here. Consider the atmospheric pressure on Venus, which is a staggering 92 times that of Earth. To put this into perspective, it's the equivalent of being 1 kilometer deep in Earth's oceans. This immense pressure is caused by an incredibly dense atmosphere, primarily composed of carbon dioxide with clouds of sulfuric acid. Yes, you heard it right, sulfuric acid. Not exactly the kind of weather one might hope for when envisaging a new home for humanity. Now let's talk about the Venusian day-night cycle. A day on Venus lasts 243 Earth days due to its slow rotation. This is the longest day of any planet in our solar system. Moreover, Venus has a retrograde rotation. Unlike most other planets which spin on their axes in the same direction as they orbit the Sun, Venus spins in the opposite direction. This results in the Sun rising in the west and setting in the east, a reversal of what we are accustomed to on Earth. The combination of these factors, the scorching temperatures, crushing atmospheric pressure, corrosive sulfuric acid clouds, and a day-night cycle that lasts longer than a typical Earth year, all contribute to the immense challenges of terraforming Venus. In many ways, Venus is Earth's twisted sister, similar in size, gravity, and composition, yet vastly different in terms of environmental conditions. The notion of transforming this hostile world into an Earth-like haven is, to say the least, a Herculean task. These factors make Venus a literal hotbed of challenges for terraforming. Now, let's look at Mars. Why is it the favored choice for terraforming? Mars, the red planet, has always captivated our imaginations and sparked many space exploration dreams. Its appeal for terraforming lies in several factors, of which we will delve into. Firstly, Mars's surface temperature varies between a chilly -80 degrees Celsius to a comfortable 20 degrees. Yes, that's right, it's not always freezing on Mars. This temperature range, although significantly colder than Earth's, is still within the realms of human adaptability. Next, we consider the atmospheric pressure. Mars's atmospheric pressure is roughly 0.6% of Earth's. While this is a tiny fraction, it's not negligible. We could potentially increase this pressure by introducing more gases into the Martian atmosphere, a step towards making Mars more Earth-like. Speaking of gases, Mars' atmosphere is predominantly carbon dioxide, about 95% to be precise. This is a crucial factor for terraforming, as carbon dioxide is a greenhouse gas. It traps heat and could help in warming up the Martian surface. Now, let's talk about the Martian day-night cycle. It's almost identical to Earth's, just slightly longer at 24.6 hours. This similarity could make the transition from Earth time to Mars time smoother for human inhabitants. Finally, Mars's axial tilt is 25.19 degrees, remarkably close to Earth's 23.5 degrees. This means Mars experiences seasons, just like we do on Earth. The concept of seasons would not be alien to future Martian settlers. So, Mars, with its colder but bearable temperatures, low but workable atmospheric pressure, abundant carbon dioxide, near-identical day-night cycle, and similar axial tilt, presents a viable option for terraforming. It's not perfect, but it's a start. Mars, despite its distance, seems to offer a more welcoming environment for terraforming, and that's why, when we dream of making another planet our home, we often find ourselves looking towards the red planet. What would it take to terraform these planets? Let's dive into the intriguing world of terraforming, beginning with Venus. To transform Venus into an Earth-like habitat, we would first need to cool it down. Venus's surface temperature, which is hotter than a pizza oven, could be reduced by using solar shades, giant mirrors that would deflect sunlight away from the planet. But here's the thing, we would need to construct a solar shade with an area roughly 3 times the size of Venus itself. To put it into perspective, that's like covering the entire surface of Asia, Europe, and Africa with solar panels, and that's just the start. Next, we'd need to tackle Venus's dense, carbon dioxide-filled atmosphere. One potential method could be using genetically engineered bacteria to absorb the CO2 and in turn release oxygen, but the amount of bacteria required would be astronomical. Think of filling up about 1 million Olympic-sized swimming pools. Now let's hop over to Mars. The red planet is a tad easier to terraform than Venus, but still presents significant challenges. Its thin atmosphere means that any liquid water on the surface would either freeze or evaporate quickly. One possible solution is to release greenhouse gases, like carbon dioxide, to thicken the atmosphere and raise the planet's temperature. However, the energy required to do this is mind-boggling. Based on current technology, we would need to use the entire world's energy production for about 1,000 years. And that's assuming we could even find enough CO2 on Mars to begin with. Then there's the issue of Mars's weak magnetic field, which allows solar radiation to strip away its atmosphere. Creating an artificial magnetic field might be a solution, but we are yet to develop the technology to do so. The process of terraforming is a Herculean task requiring immense resources and time. But who knows? With the rapid advancement of technology and our insatiable curiosity, we might just turn these science fiction dreams into reality. So, given all this data, why don't we terraform Venus instead of Mars? Well, let's summarize. Venus, our celestial neighbor, is closer to us, yet it presents extreme conditions. The sweltering temperatures, the crushing atmospheric pressure, and the constant acid rains make it a Herculean task to even consider terraforming. On the other hand, Mars, the red planet, though farther, offers a more hospitable environment for terraforming. Its temperatures are less extreme, atmospheric pressure is manageable, and it lacks the corrosive atmosphere of Venus. Plus, Mars has shown evidence of water in its past, which is a crucial ingredient for life as we know it. It's not that we are favoring one planet over the other, but the current feasibility and practicality of terraforming tilt the scales in favor of Mars. While Venus is closer to us, the extreme conditions and the enormous challenges for terraforming make Mars a more viable candidate for now, but who knows what the future holds? Maybe one day we'll be able to call both Mars and Venus our second home.